Dear student, in this video we'll see how to perform elementary transformation of a matrix. First point, if the ith and jth rows of a matrix are interchanged, we write R I interchange RJ. Second, for a non-zero real number, say k, we mean multiplying all the element of ith row of a matrix by k. Third point, Ri plus k time Rj indicate that each element of jth row is multiplied by k and then added to the corresponding element of the ith rows. Consider the example. Suppose A is a given matrix 2, 3, 4, 5, 1, 6, and we want to perform the following operation. R1 interchange with R2, then we will write this is our R1, this one is R2. So after this operation we'll write 5, 1, 6, 2, 3, 4. That is the R1 interchange with R2. Now this one become my R1 and this is R2. Suppose we want to perform this elementary operation R1 minus 2 times R2. So we need to, in this case, we need to change the R1. So we'll write this way. If you wish, you can write this way also, that I am changing R1 this way. R1 minus 2 times R2. So since we are changing R1, so R1 will change and there is no change in R2. So we'll write R2 as it is. And you can write that performance over here. So R1 is 5, 1, 6, and we need to multiply by minus 2. So this is minus 4, this one is minus 6, this one is minus 8. Add this one. So 5 minus 4 is 1, 1 minus 6 is minus 5, 6 minus 8 is minus 2. So we'll write this element with respect to here, their position. So this is R1 minus 2 times R2, and this one is a R1 interchange to R2. Consider the second example. Suppose we want to transfer this given matrix to a identity matrix. Identity matrix means we want to write the given matrix in the form of 1, 0, 0, 0, 1, 0, 0, 0, 1. This is called as the identity matrix. So we'll do this only by row transformation. That column transformation is also applicable, but it is considered as a difficult to perform, and while solving the system of linear equation we don't require this method. So transformation by row is easy as compared to transformation by column, so we prefer row transformation. So we'll write this matrix A is equal to 2, 1, 1, 1, 1, 1, 4, minus 1, minus 3. This is our given matrix, and we need to write this one as a starting with the 1. Now you can see this 1 is here, so we can interchange the first row and the second row. We can interchange first row and the second row. So my first row transformation is I am changing R1 such that interchanging R1 and R2. So you can interchange R1 and R2. So matrix A become 1, 1, 1, 2, 1, 1. Since there is no operation on third row, so we'll write as it is. Now by using this one, we'll make this one as a 0 and this one 0. So we'll use this 1 to make this one as a 0, and again using 1 to make this one as a 0. So we are changing R2 such how R2 minus 2 times R1. So since R2 is changing, we'll write all the element as it is. So first row as it is, third row as it is, only that second row going to change. Now write down the R2 element in a rough 2, 1, 1, and perform minus 2 to first R1. So this is minus 2, this is minus 2, this one is minus 2. we'll add this. So plus minus get 0. This one is minus 1, this one is minus 1. So we'll write 0, minus 1 and minus 1. Now we want to make this 4 as a 0. So we'll change R3 by R3 R3 minus 4 times R1. So first row and the second row is not going to change. So we'll write 1, 1, 1, 0, minus 1, minus 1. Since third row is changing, and we'll write the element of third row in a rough and multiply the first by minus 4. So this is minus 4, this is minus 4, this is minus 4. We'll add these ones. Plus minus get 0. This is minus 5, this is minus 7. So we'll write 0, minus 5 and minus 7. Next, we'll try to make this one as a 1, because in identity matrix this is 1 and below 1 we need to make the other two element as 0. Then second row second element as a 1 and below that 0 and above that 0. So our second aim to make this one as a 1. Here already that minus 1 is given. So if we change R2 by minus time throughout the element, so it get changed. So 1, 1, 1, 0, 1, 1, this is 0, minus 5, this is minus 7. Next, we want to make either this one 0 or this one 0. So we want to change the R1. So R1 going to change R1 minus R2. Now no change in R2 and R3. So we'll write 0, 0, 1, minus 5, 1, minus 7. And we'll write this element over here in a rough 1, 1, 1, and we'll write minus R2, all the element with the minus. So this is 0, this is minus 1, this is minus 1. So you can see 1 plus 0 is 1, plus minus gets 0, plus minus gets 0. So this is 1, 0 and 0. Next we'll make this minus 5 as a 0. So we'll write first 1, 0, 0, 0, 1, 1, and since we want to change R3, so R3 we are changing R3 plus 5 times R2. So we'll write the element of R3. Element of R3 is 0, minus 5, minus 7, and we are multiplying R2 by 5. So this is 0, this is 5, this is also 5. Plus, so this is 0, 0, 0, plus minus 0, this is minus 2. So my element reduced to 0, 0 and minus 2. Next, we want to make this minus 2 as a 1. So we want to change R3 by multiplying minus half. So you can say this one minus 1 by 2 time R3. So our element, no change first row, no change second row, and 0, this is 0, this is 1. Now we'll use this 1 to make this one as a 0 and this one is 0, but already that one is 0, so no need to change. So we want to change R2. How? See, R2 minus R3. We focus the element on the row. This is 1, so no need any multiplication, number as a multiplication. So we'll write the row which is not going to change. 1 0 0, this is 0, this is 0, this is 1, and we write the element which is going to change. So second row going to change, so we'll write down and that element operation. So minus R3 means this one, so 0 0 and minus 1 we need to add. So this is 1, this is 0, this is 0, so our second row changed to 0 1 0. Now this is our identity matrix.